6.2 today. Here we have a rectangle with a chunk taken out of it. We need to find the area. So we're just going to take the entire area and then subtract out the area of the triangle. So the entire area is going to be 40 square yards. And then if I treat that like a rectangle, the area of this is 4 yards times 3 yards, which is 12 yards. And then I cut that in half, and I get 6 yards squared. And subtract that here, 34 yards squared. Easy enough? Okay. Well, let's look at another one, just in case it's a little bit different. All right. So here, the area of the triangle is going to be 1/2 9 times 10. So that will be 45 feet squared. The area of this is 12 feet squared. So we just subtract, we get 33 square feet. All right, next one's a little bit harder. Area of a regular polygon. So they're not going to tell you any of the angles for these polygons. All they're going to tell you is the length of the apothem, or sometimes the diameter. So if you have a regular polygon, that means that all of the sides are the same length. It also means that all of the angles are the same size. All right. How do we figure out the size of one of these angles? We have two methods. One of them is we draw triangles. So we select any vertex, it doesn't matter which one, and we draw as many triangles as will fit inside that polygon. And each of those triangles has an angle sum of 180 degrees, and all of the angles in the polygon are the sum of all of the angles inside those triangles. So we have 3 triangles times 180, and that's going to give me, what, 540? And those are split evenly across 5 angles. So that is 108 degrees. That is a very, very common problem on the ACT. But there's an easier way, in my opinion. If you have a convex polygon, then the angle sum of all of the exterior angles is always 360. So each one of these angles added together will be 360. And that's true if it has 5 sides or 6 sides or 3 sides or 12 sides. It's always 360. So if each of those angles is equal, 360 divided by 5 is 70 or 82, I think. No, 72. I was right the first time. So if this angle is 72, then that angle is supplementary to 72, which gives us 108. Okay, that's going to be important for some of these problems. Also, if you take a line from the center of a regular polygon to the midpoint of one of the sides, that segment is called an apothem. Not the furry little giant mouse that hangs upside down from trees and plays dead. So that is called an apothem. If we take the same center and connect it to one of the vertices, that's called the diameter of the polygon. All right? So how do we know the area of the pentagon if all we're given is the apothem? Well, let's do this one. here is a right triangle, okay? And I know one of the sides of the right triangle is 4.5. Can I find one of the other sides? Well, I can actually figure out how long this is. How would we do that? Well, the perimeter of the entire figure is 32.5. How does that relate to this chunk? Well, there are 5 sides. If the entire figure is 32.5, then I can divide this by 5. So 32.5 divided by 5 gives me 6.5. Okay? And if that's 6.5, how big is this? How does that little segment compare to 6.5? So this would be 6.5, and that's the same as all of them. So this piece is just half of that. So we divide that by 2, and I get 33.25. You see that? Okay. Now, I know the base and the height of this triangle. So that triangle has an area equal to 4.5 times 3.25 divided by 2. Okay. And how many of those triangles are there in this figure? So if I draw them all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we times this by 10. So 4.5 times 3.25 divided by 2 times 10 gives me 73.125 square feet. Okay, let's do another one. All right, same idea here. Okay. This time they told me that the apothem is 3.5 and one of the sides is approximately 2.9 feet. So this triangle here is 3.5 and 1.45 because I cut this in half. Right? So the area of this is 3.5 times 1.45 divided by 2. And how many of those does this contain? So there are 8 sides. Each side builds 2 triangles. So if I drew them all, we would end up with 16. So we times this by 16, and that would be our answer. All right. Okay, it hasn't asked me for an angle yet. I thought some of them had an angle. All right, so this is a heptagon, which means 7 sides. We know that the perimeter is 56. So I will draw this triangle here. That length on the triangle is half as big as one of the sides. So if I take 56 and divide it by 7, that gives me each side is 8 centimeters, which means that this side is 4 centimeters. So the area of that wedge is 8.3 times 4 divided by 2. And there are 2 triangles per side and 7 sides. So we times that by 14. Okay. Let me look at one more. Oh, all right. Okay. So this is an equilateral triangle, which means all of the sides are equal and all of the angles are equal. An equilateral triangle is also called a regular triangle. In an equilateral triangle, all of the angles, not 30, all of the angles are 60. Okay? And it's asking you to use special right triangles up here. There are two special right triangles. One of them is isosceles, 1, 1, root 2, and both of those angles are 45 degrees. The other one is a 60, 30, 90 triangle, and the side lengths for that are 1, 2, and the square root of 3. Okay? Well, what if I drew a triangle that was 5 and 10? What would go here? Just 5 root 3. It's 5 times larger. So this would be 5 root 3. Okay. If I had a 1/4 here, that would be 2 divided by 8 is 1/4. So this side would be 1 divided by 8, and this would be root 3 divided by 8. And that's how we use special right triangles. So if I draw this triangle here, and all of the, that's an apothem. So the apothem is 8. Okay. What is the area of that triangle? Oh, it's going to make you do the formula, huh? I don't like formulas. Nobody remembers formulas. I just like to figure it out. Okay. We're going to have to look inside here. Okay. The area of a regular polygon with an apothem having length A units and a perimeter of P has the following formula. The area is 1/2 times the apothem times its perimeter. They didn't tell us the perimeter, did they? Find the area of equilateral triangle with the perimeter. So we have an apothem of 8. Oh, I see what it did. Okay. I see what they did. Oh, and now it's a different problem. Okay, so here, all of the outside angles add up to 360. There are 6 of them. 360 divided by 6 is 60. So the exterior angle is 60, which means the interior angle is going to be 120. But if I draw this shape, now I have my 60, 30, 90, and I know that this side is a 9. And if I draw my special right triangle, the short side is a 1, the long side is a 2, and nope. The short side is a 1, the hypotenuse is a 2, and the middle side is root 3. And this is 30, 60, 90. Okay. So if I set up a ratio, 9 divided by root 3 is equal to x divided by 1. These are similar triangles. 9 divided by root 3 equals x divided by 1. Cross multiply. X root 3 equals 9. So we would divide this by root 3. X equals 9 over root 3. I'm not allowed to leave that in its current form. So I times it by root 3 over root 3. Did I mess up? Oh. So x is 9 root 3 over 3. This simplifies down to 3 root 3. Okay, so this length here is 3 root 3. What is the area of that triangle? 1/2 times 3 root 3 times 9. That gives us this area. How many of those triangles are there? 6. So that becomes 3, 9. So I get 81 root 3 centimeters squared. Now, there is an Apothem formula, but I never use it. Like on the ACT, are you going to remember what the Apothem formula is? I'm not. In fact, I forget what it is every year. I just figure them out. If you like the formula, go ahead and use the formula. So let's go back to one of those that just had a triangle. Here we go. Okay. So this is a 60-degree angle. So if I draw this triangle, 30, 60, 90, and I know that this is 6. Okay, and I want to figure out what that is. Well, my special right triangle, 60, 30, 90. The short side is 1, the hypotenuse is 2, and the middle side is root 3. So 6 corresponds to 1. 6 over 1 equals x over root 3. So we cross multiply. X equals 6 root 3. So we put that in here. 6 root 3. The area of this triangle is 6 root 3 times 6 divided by 2. And if I count how many of those there are, 1, 2, 3, 4, 5, 6 of those. Oh, I said 6 in the last one. It should have been 12, huh? My bad. There were 12 triangles in the last one. This one has 6. And we multiply that out, and anyway, that is our answer. That's it. Go for it. Oh, okay. Let's find the other. I didn't know there was another one. Not that one. Okay, what does it give you? So like it tells you this, and how long is it? Just 12. That's it. Okay. So if we don't know that that's a 6, but we know that this is a 12, I can draw this triangle, and this is a 6. Right? So this is 6, and this is 30, 60, 90. So my reference triangle is 30, 60, 90. 1, 2, square root of 3. So 6 corresponds with root 3, and x corresponds to 1. So 6 over root 3 is equal to x over 1. Cross multiply. 6 equals x root 3. So we divide by root 3. 6 over root 3 is the same as 6 root 3 over root 3 times root 3. That is 6 root 3 over 3, which just becomes 2 root 3 because we can pull out a 3. So the apothem is 2 root 3, which means the area of this little triangle is 6 times 2 root 3 over 2. You can cancel those. So the area of that triangle is 6 root 3, but if I count them up, There are 6 of those. So we get 36 root 3. And on that hexagon problem, I said there were 6 triangles, but there were actually 12. So that answer I had was wrong. Yeah. Yep. So you would say 36 root 3 meters squared. Is that what you're asking? Yep. Okay, it doesn't want the decimal answer. It wants the exact answer. So just leave the root in there. All right. Now get to work.